Hi everyone, we're just testing out the slides and the guest lecture is just starting at 2 o'clock, so just hang in there. Just show my slide. Right, Belinda, are you able to see this?
Yep, that looks good.
Mm-hmm. That's good, and I'm going to just play the video.
Close to the heart of Melbourne, Swinburne is
Don't think there's any videos in there for the rest of the slides, so
No, not that I could see, so it should be okay.
it's all right. I will also try to make you co-host. And then if you want to try to move around and maybe try the annotate.
Gosh.
Yep, looks good.
Okay.
Okay.
Clear all. Done.
Okay, cool. All good. Thanks.
Awesome. Thank you. Nice and easy. I'll keep myself on mute until before the presentation.
Thank you.
Thanks, Shin.
Thanks. Hello, students. Good morning, everyone. Thank you for being on time. We're just starting at 10 o'clock, so just hang in there. Meanwhile, don't forget to fill out your attendance form. I think that's sent through by Sharina. Hi, Dr. Carola. I think we're just waiting on a few more students. Hi, Belinda. Hi, Rifai.
Hi, Shan. Hi, Belinda. Can you hear me?
Yes, yes,
Ah,
I
that's
can
good.
hear you.
Hi.
Good. There's a lot of people here.
Yes, we
Carola
have
here as well. Yep.
Dr. Carola here already, and
Hi, Clara. How are you?
we also have Sharina from
Serena?
UMN's.
Okay.
She's the coordinator for
Sure.
informatics community.
Yep. Serena. Okay. Just me write the name.
And just trying to go through the list of attendees. We have the lecturer here as well from informatics department, Mel Jono. And I think we're probably still waiting for, not too sure if Dennis is joining us, who is the joint degree coordinator, and also the head of informatics department, Melinda. Hello.
Good morning.
Morning. Moljona, is Dennis joining us today?
I think so.
Let me just give him a minute.
I will try to. Okay, let me see. Yes.
Yeah, I think Dennis is he's just logged in. Good morning, Dennis.
Yeah, morning, Shan.
Are we still waiting for more students? I think we've got 128 people at the moment.
Yeah, no problem.
Yep. Dear students, please don't forget to fill out your attendance form as well, please. Dennis, should we start soon?
Yeah, okay, no problem.
Yeah.
Yeah.
I'll pass the floor on to our host, which is Belinda today. Thank you.
Thank you, Shen. Good morning, everyone. Thank you for taking the time to meet with us today. My name is Belinda, and I'm here to talk to you about our university, Swinburne University of Technology, and about our partnership with Universitas Multimedia Nusantara. So after my introduction, I would like to welcome Dr. Carola to speak to you about data visualization. And after that, there will be a quick Q&A session. So you're welcome to turn on your microphones and ask any questions that you have. Or if you'd like, you can just put the question directly into the chat box, but just make sure that you do have it addressed to everyone so we can see that. Next slide, please. So at Swinburne, it's customary for us to start all of our presentations with an acknowledgement to country to respect and recognise the traditional owners of the lands in Australia. So I would like to take this time to respectfully acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners of the land on which Swinburne's Australian campuses are located. And I would like to pay my respects to their elders, past, present and emerging. Thank you. This is just a slide of our campuses and locations that we have at Swinburne. So we have our 3 campuses in Victoria, which are Melbourne, in Montana and in Croydon, one in Sydney, a campus in Sarawak in Malaysia, and also campuses in Hanoi and Ho Chi Minh City in Vietnam. I would also like to point out that despite the fact that we are currently in a pandemic and most of us are working, learning from home and doing all of this online, Swinburne is one of the first Australian universities to begin offering online teaching and online qualifications through our Swinburne Online. So this is something that we're very experienced in delivering online teaching. Our location is, our main campus is in Hawthorn, and we are just 10 minutes away from the city centre of Melbourne. And we are very lucky to be one of the few universities in Australia to have a train station right in the middle of our campus. Glenferrie Station, meaning that our students can not only get into the campus very easily by train and just sit on the train for maybe 5 stops into the CBD, but it also makes it very accessible to visit the city centre of Melbourne and explore everything our city has to offer. Our campus is, like I said, very close to the city. It's abundance with green lawns and trees, and it's quite compact, so it's very easy for students to travel from class to class. And many of our buildings are structured so that they are basically one-stop shops for our students. So you can have a look at any student union things, you can go to a medical centre, you can ask for help with careers and employability, with your teaching and learning, all in the very same location, making it very easy and accessible. We are lucky to be also based on Glenferrie Road in Hawthorn, which is a beautiful strip of shops that has many different kinds of shops and cafes and restaurants and entertainment for students to take advantage of. So this picture here is our Lido Cinema, and it is a cinema that students can get discounted movie tickets to. And Swinburne students also have access to our to the Hawthorn Aquatic and Leisure Centre just down the road, where Swinburne students can get free access to the pool for a swim, or if you'd like, there are also discounted gym memberships. Next, please. This is just a slide about our rankings. So we are ranked number 45 in the world universities under 50 years old, and ranked among the top 300 in universities worldwide. And we are also highly ranked in the areas of art and design, computer science and engineering, civil engineering and law. We are also AACSB accredited, and this is something that we are very proud of because it's only offered to the top 5% of world universities offering business degrees. Next, please. One of our new strategies that we've implemented at Swinburne, our 2025 strategy, is to incorporate several moonshots, and one of those is to ensure that all Swinburne learners get work experience as part of their studies here. So that is our moonshot number 1, and moonshot number 2 is to ensure that every Swinburne graduate gets a job at the end of their studies. But how are we doing that? We are doing that through guaranteed real world experience. So making sure that the industry connected learning opportunities are incorporated into all of our courses, So this can be anything from placements, internships, and industry-linked projects that students get a chance to experience. And it also gives students an opportunity to work with, for industry partners. And we find it's a really valuable way for our students to obtain authentic real-world experiences that is relevant to their course of study. So not only does this make our students more competitive by having a better looking CV at the end of their studies, but it also helps to develop their professional knowledge, their skills and attributes, and start building those professional networks and those career connections right from the start of their studies, not at the end. Our students from this model, we're also able to start exploring some of those career options in a more advanced and tangible way, and start looking at what their theory they're being taught looks like in practice. Next, please. This is just a quick video that I'd like to play for you now, just about Swinburne. So thank you, Shen.
Close to the heart of Melbourne, Swinburne is where thinking and technology meet for innovation. In our state-of-the-art factory of the future, industry partners explore ideas for manufacturing next-generation products. At our Digital Innovation Lab, cutting-edge research integrates digital technologies into health, manufacturing, social science, and smart cities. Part of a network stretching from Helsinki to Shanghai, our design factory lets minds from all disciplines co-create and address complex problems in society. Digitisation and Industry 4.0 means that the workplace of the future will look vastly different, but Swinburne graduates will be ready for it all. We're developing courses founded on digital problem solving, collaboration, interpersonal communication and leadership skills. We're focusing on building partnerships with institutions, governments and industries. We're achieving excellence in providing offshore teaching programs, high-impact executive training solutions and comprehensive global student mobility initiatives that support educational outcomes in an international context. We share AACSB accreditation with just 5% of the world's top business schools. Times Higher Education ranks us in the top 400 universities globally. We put our students' experience first, and it shows. 180,000 graduates from every continent can't be wrong about the value of a Swinburne education. With partners in over 40 countries and a proven track record internationally, we are so much more than just a university. Swinburne has a truly global presence, and we look forward to working with you.
Thank you. This is just a slide to talk a little bit about our schools and departments. So at Swinburne, we are structured into 6 separate schools. I won't go into too much detail here, but you are more than welcome to have a look at the slides after this presentation. Thank you, Shen. This is our pathway through UMN to Swinburne. So students who complete the first 2.5 years of the Informatics and Joint Degree program can articulate into our Bachelor of Information and Communication Technology with a major in software technology with only 1.5 years remaining. If there's any other questions that you have about this pathway, please don't hesitate to reach out and we're more than happy to have a chat with you. But now I'd like to pass on to Dr. Carola, who will be talking to you about data visualization. Thank you.
Great, thank you so much for that, Belinda. And it was really nice to watch that video and see so many people that I knew. I was like, oh my gosh, I knew that person. So I know that everyone in that video are genuine Swinburne people. So that was really cool. Okay, so can I control this? Yeah, so you can control the screen. Am I able to change the slides or just? I'm just wondering, can I change the slides or?
Oh, yes. Yep. Please feel free to click through.
I'm not sure how, sorry. I'm just trying to work out how I might do that.
Let me just try to give you remote control again.
Yeah, that'd be great. I think that's someone trying to play that.
There we go. Yeah.
Am I?
No worries. All good.
No. All right. Well, maybe we can have a go. Can anyone see my pointer on there? No. That's someone else's pointer.
Hang on, I think the control has been given. I'm not too sure what's happening there. I'll just stop and try again. Giving remote control. There we go. Yep. There we go. I can see your mouse. Yep.
Oh, okay.
Oh.
Awesome. Ah, great. Okay. All right. If I can't see my mouse, it's a problem. Unless we've been doing some scribbles on here.
I think because I have to mute myself, so I'm just gonna drive the mouse over to my screen and mute myself for now, and then I'll pass on the mouse back to you yourself.
Okay.
Yep. Oh, sorry. I'll just drag it over from you. Hang on 1 second. Yep.
All right. Ah, awesome. Okay. Sorry about that. Okay.
I'm not muted, I think.
Yeah, I'm Carola, and I'm here to talk to you a little bit today about data visualization, in particular, how we might go about designing effective visualizations. So, no, I've lost control again. Ah, we got it. Can you maybe move the next slide? Ah, here we go. Okay, so you might be aware that there's a lot of data floating out there in the world, and some of what you're doing in your course might be about, how to process that data and make sense of that data. And you may, can we change the slide? Is that me changing it or you? Ah, here we go. Okay, worked it out. Okay, so you may be familiar with, maybe I can try and get rid of it. Okay, I'm not quite sure what's going on here. All right. Sorry. So you might be familiar with the data visualization, or sorry, the data science process, where we start with data out in the real world. And there's a lot of that floating around these days. We collect it, we process it, we clean it to make sure it's all neat and tidy and no things that are going to throw our analysis out. And then we might look at exploring the data and maybe applying, your machine learning, algorithm, statistical models to that. And I guess given by the sound of your degree, that's the sort of thing that you've been doing. But once you've processed all that data, somehow you've got to communicate that to the user, to the people who are actually making decisions and trying to make sense of that data. And that's where data visualization comes in. Okay, so data visualization is kind of like that end point of the data science process. And it's a really important one, because if you can't actually communicate, then all that work you did beforehand is kind of useless. So one of the sort of the big names in data visualization is Edward Tufte, and he kind of pointed out that when you're designing information design like a data visualization, the principles are kind of universal to everybody. It doesn't really matter about your language or your culture or your problem solving skills, because a lot of the principles of designing a data visualization is based on what goes on between your eye and your visual processing mechanisms, part of your brain at the back of your head. So it's very much a very, a physiological process that a lot of our data visualization design principles are based on, which makes it really nice to work with, like, cross-culturally and things like that. The real issue though with that is that because the perceptual processes are really important, so we need to understand how those perceptual processes work, otherwise we won't be making a good visualization. So let's have a look at how perceptual process might influence the way that we interpret a data visualization. So most of you are probably familiar with a pie chart, so you've probably seen one of these. I'd like you to have a look at our 3 pie charts and see if you can work out which color segment is the biggest and the smallest in each of these pie charts. So I'll just give you a minute to kind of look at that and think, oh, which one's the biggest and which one's the smallest. All right. Okay. So maybe you've got that. All right, got a decision. Keep it in your head. All right, now imagine though, think about how perhaps difficult that was. And imagine though if I gave you this version of that data. Now can you see which is the biggest and the smallest? All right. It's the same data, but I think if you're looking at this now, you'll go, oh, it's so much easier to do it in the bar chart. Okay, so with our pie chart, it was really hard to tell the difference between, find differences between the segments, whereas with our bar chart, we can actually quite quickly see which one is the smallest and which one is the largest. And the reason for that is because of the way that our retina, the back of our eye, picks up information from the visual environment, the way the cells fire and stuff like that. Our visual system is actually tuned to pick up positions like positions in length, differences in length and differences in position in both, the vertical and the horizontal plane. So these kind of positional information, we're really good at interpreting and judging the differences for. So they're very effective. Whereas things like the tilt, like we've got in our angles here in our pie chart, we're a lot less efficient at doing that. We're not very good at telling the differences compared to this other type of scale. In this one, we're also using area. And again, area is also, middle effective in terms of us being able to process it quickly. And then as we go down, we've got saturation and volume. So we've sort of got the least effective and the most effective at people being able to use that information visually. So let's have a look at some other examples about that. Well, actually, before we do that, let's have another look at a pie chart. So pie charts are used quite a bit, but sometimes they're not really used very effectively. So if we have a look at this pie chart, we'll see that I think there are like 20 categories or something here, or maybe even more. There's a lot of categories here, and it's pretty much almost useless because there are so many categories, there's so many different colors, and trying to match up the color and the category that, okay, so what's that 3%? Which hotel is that? It's really difficult to tell. So when you're using a pie chart, not only you need to consider that people are not very good at discriminating and seeing small differences, also they become quite ineffective when you've got a large amount of categories. Now we can somewhat improve that by maybe using a different style of, legend. So instead of having our legend off to the side, we could label our parts of our the segments in our pie chart. But again, there's a lot of information here that are actually repeating colors and things. And it is a little bit hard to, to see those finer segments and make comparisons. So again, a pie chart, when you've got a lot of comparisons, is not going to be great. Instead, you might look at, a bar chart. Okay, so like we had before, because you can see those differences quite well, and particularly if you order it, so you allow people to sort it, then you can see those differences. One of the things that you might notice that you might not have seen a lot, perhaps, is like the vertical scaling. So the vertical position of this pie chart, this bar chart, is useful because we can put in our category headings. Okay, so that means that people can read them easily, because if you have it on a horizontal, all the text is tilted, otherwise you don't fit it in, and it makes it much harder for people to read and use. And so that's why this can be kind of effective. It's also nice if you're displaying on a web page, because people can vertically scroll quite well, but horizontal scrolling is not quite as attractive or common. Oh, sorry. My slides are going in the wrong direction. Sorry. Belinda, it's going forward, but not backwards. Here we go. Here we go. Now it's trying to catch up. Are we there? Okay. So another thing that people sometimes do with charts is try to make them decorative. So they put a lot of decorative detail in a chart, and that can be kind of counterproductive because you're hiding the data in all the decoration. The other problem with using decoration like 3D type stuff is it actually quite hard for people to interpret depth. Okay, so this one has depth because it's going, you know, into the page, and it's also trying to use volume. All right, so the size of these objects for people to compare with, and that is really quite ineffective. All right, so if we see on our chart, so trying to determine the difference between that blue and that yellow is really quite difficult on a chart like this. So if you want to make it hard for your readers to interpret their data, then do it like this. But otherwise, you're probably better off helping them out by doing something nice and flat so that people can easily compare. All right, well, let's get into something a little bit different, and that is our we've got a map here, which is sometimes this can be a nice way to display information about different countries, because if we wanted to do different countries in a bar chart, we would be like, our bar chart would be super long, and that's only a small selection of countries. It's not the same data, but it goes on and on and on. All right, so using a map can be a really nice way to kind of like indicate, you know, countries and information about countries. Now, in this chart, we're using circles to indicate our data. All right, so we've got an area of our circle, so a big circle, more things, a little circle, less things. Okay, so the magnitude is being represented by the size of the circles. So that's what we call sort of a bubble chart. Now, there's a couple of things that you're probably looking at this and you might be able to think of some things as to why our bubble charts are not particularly effective sometimes. Well, this particular chart using the map is not that effective. And that is that we're really having trouble seeing what's going on in here. Okay, so that's where we have an advantage doing stuff on interactive systems, like on a web page or something, because we can actually build systems that we can zoom in. So we can still make use of this if we allow people to zoom in and look at the data and see that data a little bit better. All right. Okay. And so, you know, we sort of have a trade-off here between having that big space being taken up by, you know, a long bar chart, or maybe using a different way to represent our information, a less effective channel like our area. Okay. So there's, you know, trade-offs there. All right. So why would we still want to like use area? So even though it's not that efficient or sorry, that effective in communicating, you know, small differences, well, one of the really cool things about that is that we can start kind of like loading different channels. We've got multivariate data, like with a, you know, a couple of different dimensions. We can start loading different data into the different channels. So in this chart, which is from Gapminder, which I highly recommend you have a look at Gapminder. It has some really nice interactive features. In Gapminder, we have life expectancy, which is running up on the y-axis here. So we're actually using vertical position to indicate differences between the data points. And then we've got income running along the x-axis. And then we have the size of the circles. And the size of the circles are population. Okay, so the size of the circle, so we can add in our life expectancy, our income, and then we can add in that extra dimension by using the size of the circle to indicate that third level of data. And so the bigger the circle, the more the population, the smaller the circle, the less. So this one is China. That one's India, I think. That one's China. This one's Nigeria. The actual visualization has mouse overs. So when you mouse over, you can get that information. So those kind of tool tips are another thing we can do with interactivity, which is kind of nice to use. I think we've got Japan here. I think that's the USA there. I think Australia and New Zealand are hiding in there somewhere. I think that's South Africa there. So you've got this kind of, you know, countries across this, you know, data set. There's one more piece of information encoded into this data visualization, and that is the world region. All right, so this is, world region is not like a quantitative data, so it's not bigger or smaller than anything, it just is a category. And so they've represented that with the color. So we have the green color For the Americas, you've got your sort of Asia and Central Asia kind of bits. Everything is in, you know, your main continents in different colors. And so we can see also the continents. So this data visualization is packing a lot of information in there, you know, your life expectancy, your income, your population, and your world region. And then the interactive features take it even further than that, allowing you to customize what you can see and things like that. So it's a really nice visualization to have an explorer of, to see how they've done it, let alone the interest that you might have in the actual data. They have a lot of interesting world data sets in there. Now, one of the things that you may or may not have noticed in that prison one, if I can get it to change. I'm just trying to move the slide. Sorry, the slide is not moving. I'm not sure if you can move it, Belinda, or I'm not sure if we've gone into some kind of different mode, but oh. I think we've gone somewhere else altogether. Ah, back there again. I am controlling. Sorry, I just can't seem to change my slide.
Sorry, Shen, did you want to try taking over control to reset
Yeah.
the slide? And
Yeah,
then...
I just can't advance it. It's not moving.
Oh, yeah. If you want to just leaving the mouse for a moment while Shen resets it. Thank you. So if you wouldn't mind just, I think because you've got Shen's mouse. So,
oh, sorry. I'm just.
That's right. Perhaps I'll try.
If it's possible.
Sorry, everyone. I think there's just a little bit of computer issues at the moment. So hopefully this will come back soon.
Yeah. Let's look at okay, well, I mean, while we're looking at this slide, a couple of things that I could perhaps point out is that another issue with this particular graphic is we're looking at income. All right, and so with income, you get into a lot of tricky situations because if you're comparing years, money changes. So what you could buy with, you know, $1 20 years ago is quite different to what you can buy with $1 today. So when you're doing something like this graphic from Gapminder, which are looking at income across, you know, many different years, and also from countries, from, you know, many different countries that use different currencies and things, then it's really important that you try to relativize that value. So with our gap finder, they've got like per person, GDP per capita, inflation adjusted. So their measure of income that they actually create is something that's actually based on, an adjusted version, so that you can meaningfully compare between, countries with, a very low kind of living costs and countries with high living costs and things like that. So that is something that I want to talk about next with our prison data. So remember with our prison one that I looked at with the big purple circles. So with that one, that was actually looking at the population of people in prison. So the actual number of people in prison, and I think it was something like 2 million in the US are in prison. But if we think about, how many people are in the US, there's 330,000 of them in the US. Whereas in Australia, I think we've got like 25 million, and they've got, 330 million. All right. So maybe they've got 2 million people in prison because, they've got more people. All right. So when you do a comparison between, say, something like countries, you need to make sure that you're comparing equal data sets. So I don't know, have we got any progress on our slide?
Yes. Can you see the screen now?
The next slide.
Next one after this.
Do you want to move it?
Yep.
Okay, maybe we can try that and see how we go. Better that we're moving slides than I can.
That's right. Is this one okay?
I need the next one.
Next one.
Unless I'm looking at I'm looking at the Gapminder one, unless I'm somehow behind you.
I think I have Chloropleth up on mine.
No, I've got something. Maybe that's the problem, because I'm stuck on a different view. I'm actually stuck on the same one that I was on originally. So maybe I need to log out and log in again.
That's right. If perhaps Rifai, if you're able to confirm what everyone else is seeing, otherwise then maybe it might be me. I can change mine.
All I can see is the Gapminder one, which says 2019. Yep. Okay, so some other people seem to be stuck on Gapminder as well.
Okay.
Yeah. Is it possible for me to share my screen? Because then I can pull up my version of it.
If you'd like to try that, yes.
I'm not sure if I can. I don't know if I have the option because I have my role.
I think you're co-host, so you should be able to just, if you click share screen.
Stop participant. Okay, so sorry, I've just stopped that. So now if I go to my PowerPoint, share, and then if I play, if I get on my right slide, sorry. Okay, now can you still see gaps? Can you see the next slide?
Yes, area versus radius coding.
Okay, beautiful.
Great.
All right, so this was
Thank you.
One of my next points. Okay, great. Okay, now I'll try and speed up so we can get through. Okay, so one of the tricky things when you're doing circles is that how you map it. So you want to make sure that when you're mapping your circles, if you're doing a bubble chart, is that you don't use radius as a thing that you're mapping, because radius doesn't track with area. All right, and that can be a bit of a problem because we're keyed in to look at area. So you must make sure that you track your data according to the area and not to the radius. All right, so I was talking about, our population, 2 million, a lot of people in the United States, not very many people in Australia. And so this chart tries to kind of, I guess that fixes this problem because it actually does it per 100,000. Okay, so instead of that, we've got our per 100,000. And so, yep, that's great because now we're looking relative, we're comparing apples and apples rather than apples and oranges, but we can still see that the United States is sticking up out there. And the reason we know that is because we've got this magnitude scale here, which is saturation. And so we can see darker colors, higher numbers, lighter colors, lower numbers. Now we still have some issues because it's way down here with effectiveness, because it's hard. Okay, so how deep is that shade of browny color? Is that, you know, lighter or darker than, you know, Turkin, you know, well, China or something like that? Is that darker or lighter than whatever that country is there? It's kind of hard to tell. So, you know, saturation is not great, but it does give us that nice kind of overall picture. Now, sometimes when we're using chloroplasts and stuff, that people can get a little bit excited with color and can make some kind of bit of mistake. So this one is showing life expectancy. And the problem is that if we just look at this chart, if this was something, how do you tell what's high life expectancy and what's low life expectancy? It's really hard to tell with this chart, like, because blue is not necessarily bigger and red is not necessarily smaller. And it is trying to tell you, you know, longer and shorter with life expectancy. You have to literally go to the legend to try to work out what's going on. All right, so it turns out that the dark blue is high life expectancy, and the reds are low life expectancy, which kind of makes sense because you've got Africa is very red and US and Canada is very blue. But visually, you can't just look at that and know which is high and which is low. You have to actually apply what's in your front brain to try to work that out. So not very effective using this color to represent magnitude. In fact, it's only good for categories. So if we want to do that, you know, a map like this or a data representation like this is much better because we've got our saturation and we can easily see, you know, the dark, higher life expectancy, light, lower, and it really jumps out through our visual processes. We don't have to think about it and try to work out what matches. Our visual processes just tell us straight away what the story is. I might skip this one because we're probably going to be running out of time, but if we've got time, I'll come back to it. One of the things I might mention, although it's kind of a little bit related to some other things I've missed, but if you're designing a visualization that has, you know, you're going to be using color a lot to indicate stuff. So you're using, you know, saturation, for example, to show a magnitude, then I highly recommend that you go to a tool like Color Brewer. So Color Brewer will help you select colors that match and work for your visualization for your particular situation. So in this one, it's actually, we've got three, you know, levels of data that we want to represent. And I've just picked the kind of the, you know, orangey brown color, and it will actually pick the shades for me. So we'll actually make sure that you've got the right distance between the different shades to actually show the different categories, you know, nicely. And, you know, you can play around with which one that you like. All right. It also has ways that you can look at doing a diverging scale, which I would have looked at perhaps if we had more time. We still have time, I might go back to it. And also for qualitative data. So this helps make sure that you've got a really even color scale. So nothing jumps out. It's all nice and even. So definitely if you need to pick colors for a project to represent some data, then have a look at Color Brewer to give you those nice values for that. Another item that is good to think about is, or another type of chart that we can look at is our heat maps. I'm not sure if you've seen a heat map before, but these are kind of nice if you've got a really sort of dense data set. So here we're looking at the number of polio cases in the US, and we've got all the states of America down here, and we've got our dates running across here, our years. And that could be a really dense data set. If you're wanting to draw like line charts or something, you would have, you know, millions of lines going everywhere, and maybe some small multiples, like little small graphs or something to try to, you know, get all that together. But a heat map is really nice because you basically just, you know, run down the squares and you color in the square, you know, to represent the data. So in this one, you know, you'll be aware that we've got our, you know, this is not a great color set because we're using a rainbow scale. All right. And we've already talked about that idea of the rainbow scale not being great. But it does kind of show that we've got, you know, there's a change. So there's a lot of cases of polio before we have the vaccine, and then there's less cases after the vaccine. So it does kind of show that. But the problem with this chart is once you start thinking about a bunch of different users that might be looking at data like colorblind people. So if you're looking at, you know, you might be aware of color blindness, or a certain percent of the population have a problem with, sorry? A certain amount of the population have trouble with color. Okay. I'll come back to that in a minute. Yeah, I think that, yeah, there's a nice comment there, a nice question about sort of unwritten rule. And I think there does tend to be, like, I've only ever seen light colors representing like the lower values and the dark colors representing the darker, the higher values. So because you're looking at saturation, so literally saturation is about more and more color. So more deeper, intense color. So it does naturally map to like a bigger magnitude of something. So absolutely. So with color blindness, you know, about 8% of males are colorblind and about 0.5% of females are colorblind. So you need to think about them. And with a colorblind person, this would just look like a mess of dots. But for a non-colorblind, you'd see a 74 here. A normal vision person will see 29 here, and a colorblind person will see a 70. Okay, so there are differences in the way they can perceive color. Now, if we take that heat map and we throw it into another nifty little tool, which is called, you know, there's a color blindness simulator. So we can put our images in here. You can also do this like with web pages, but you know, this one's specifically for images. You put your image into the color blindness simulator, and you can pick what color blindness you want to show or how you want it to look, and then they'll give you a simulation of what it looks like. So we look at this and we'll go, well, it looks kind of similar to what the other one did. You can see the vaccinations and where it changes and stuff. But if we have a closer look, we actually see that we're doing our color blindness, people with color blindness, a really big disservice here. So if we actually look closely, and I'm mapping the exact same areas here, we've got this green color here, all right, which on our rainbow scale, it's sort of about here. And then we've got our red color, which is about here, okay? So that's great, that's our normal thing. But if we go back to that green square for a colorblind person with this particular color blindness, that green, it kind of maps to this area over here. But it also kind of maps to this area over here, which is the red one. All right. And so our red value, yep, that's up here, but it could also be that one there. So we basically aren't able to tell the difference between the red and the green squares. All right. So for the colorblind person, it looks exactly the same. You know, and green is really low polio cases and red is really high polio cases. So it's really misleading. So if you're, you know, doing visualizations, ideally you want to check for color blindness, and there are some other processes that you can do, which is one called daltonization, where you can actually run an image through this process, and it will actually make your image colorblind friendly. It will change the colors for them, but it will make it so that they can see the differences, because often it's more about seeing the differences. But we could simply fix this one by using our old friend saturation. So this is a saturated scale version of our heat map. And if we have a look in the color blindness chart, we can see that it looks pretty much the same. All right, so that one up there, that one up there, it all kind of matches. It's just one is a kind of red color and the other is kind of a murky green color. Not the most attractive, but at least it's not misleading anymore. Okay, so it's actually showing the actual data the way it should be shown. All right, so let's have a look. All right, so we've got a little bit of time left, so I might just quickly go and have a look at that data set. We didn't quite have time to, because I thought we might not, because it's kind of an interesting one. So this one is something that I snapshotted from our local newspaper today about COVID cases in Melbourne. And it's kind of like a special variety of our chloropleth, and it's using a divergent scale. All right, so what this chart is trying to show is whether cases in particular areas of Melbourne, all right, that's a C, but this is all areas of Melbourne, whether the cases are going up or whether the cases are going down. All right, so we've got our blue area here is cases decreasing, and our reddish kind of scale of colors is colors increasing. All right, and they've actually made like that 0 point. It's kind of like above sea level and below sea level. They're quite different. They're not really on the same kind of scale to a certain degree. So this is kind of transform data. And so you've got this kind of, you know, two different saturation scales working together to give you that picture. But this chart also kind of shows a bit of a problem with the sort of the using the chloroplasts, and that is that we have some really large areas here that are really red, and they're like, oh my gosh, cases increasing. Oh, panic, panic. Okay, we are panicking here a little bit, but probably, you know, not too much. And you sort of go, oh, there's a lot of red. It's just looking really bad. Okay. But remember, this is just indicating the kind of the cases increasing or decreasing. The chloroplasts don't tend to indicate, like, they can be misleading about the actual size, like, because in fact, there are not many people living in some of these areas here. All right, there's a lot of people living in here, but not many people out here. So in this article, they've actually got an interactive feature where you can toggle to a map of circles. All right, so here we've got our area again, and we've got the same map, but now you can see it's actually also including the population that's affected. Okay, so the number of cases. So Joy, we've got where the cases are decreasing a lot. There have been a lot of cases, but this spot over here, even though the cases are increasing, there's not a lot of them. All right, whereas over here, there's an increase and there's a lot of them, and over in these suburbs as well. Okay, so this chart gives us a little bit of a different perspective. We don't see that sea of red. We can actually see those kind of, you know, the populations that we're talking about as well. So, you know, sometimes you need to look at data from kind of 2 points of view to get the full story. All right, well, I think that's about good for time. So thank you very much today for giving me some time. And we've talked about a bunch of different kinds of visualizations. I mean, mostly kind of simple ones, but I just wanted to give you a feel for some of the guidelines. The unit that I teach this in is called data visualization. It's actually a 3rd year unit. So in this unit, we go through all of this kind of stuff, different ways of designing not only the visual side of things, but also the interactivity side. And we do, you know, program these into interactive kind of web pages and stuff like that. So there's a bunch of kind of different principles that you can learn to apply. And then just some final last words. I mean, working in IT and, you know, machine learning and things like that, you're probably all aware of the importance of us, you know, using the data that we've got. And I think this quote is still kind of holds true, that, you know, being able to use this data and communicate with it is a really important skill that is going to be, you know, very useful now and going into the future. Okay, well, that's all I've got to say. Thanks, Belinda. So I'll hand it over back to you.
Great, thank you. And I'd just like to open it up to the students if there are any other questions that we have that we'd like to ask of the Carola while we're here. I think you've explained it too well. There's no questions.
Sometimes.
But that's okay. I think if anyone has any questions afterwards, or if you want to have a think now or add them to the chat, we can always pass anything after the session on.
Sure. All right, do I need to, maybe I can stop sharing and
yep.
Sharing.
Great, thank you. I think we might be okay unless people are a little bit shy. If you don't want to turn your microphones on, you're more than welcome to add your questions directly into the chat.
Sure. And sometimes it takes a long time to type as well.
That's right. So we might give them a minute or so.
Hi, I want to ask a question about data visualization. Is it okay?
Yeah, absolutely.
Okay, so my name is Nicholas Duyarto. I'm from UMN. I'm a final year computer science student, and I want to ask something. It might be a bit off topic, but I want to ask about how did you prevent yourself from getting like copyright laws and privacy issues? Because we know that sometimes all of the data in the not all data in the internet are copyright free, and sometimes
Yes.
people do not want their data to be used by other people. While I think that the chances of being sued over using data for academical research is really small, I want to know how do you like minimize the chances of being sued? I'm not a lawyer, but in Indonesia, it's actually get out of jail free card kind of thing, because in Indonesia, if you cite your sources or at least you acknowledge your source, it's basically you cannot be sued if it's in Indonesia. So what's it's like in Australia? Thank you.
Well, you know, every country does have different approaches to privacy. But certainly when we're looking at, you know, the data science process, when you're thinking about, you know, setting up a question that you want to ask, working through the data, one of the issues you have to ask yourself is about the, you know, the privacy issues that might be in your data. All right. And that's definitely important, particularly I think in things like health, that can be really problematic because people are giving away a lot of health data, and what happens to that and how it's used is kind of really quite sensitive. So, I mean, to some sense, you know, there are a lot of data sets that are out there that governments publish and that people publish. And I'm assuming that if it's already published and you cite it, then that's fine. But if you're scraping it from an app that people think that they're, you know, they've got their privacy, like, for example, one of the big things now is, you know, tracking of female cycles. You know, the female cycles and stuff. And these apps have been, you know, women have recorded their cycle. This data then goes out to the company, then they sell it on. And then they know where people are in their cycle, and they can, oh, this person might not be feeling all that great. Maybe we can sell her something while she's, you know, feeling a bit emotional or something. And so that becomes a real ethical thing. But yeah, it's going to be about how those apps are collecting things and, you know, looking at how that data is collected, if it's within the privacy guidelines and what people expect. Yeah, it's a hard one, but yeah. And just because something's published also doesn't make it ethical too. You know, that is the other thing, because sometimes you get data dumps that, you know, are not maybe done legally. And even if you reference them, it's probably not a good idea ethically to use them. So yeah. Good question. It's a big issue in data at the moment, you know, with Facebook and, you know, all those data collection mechanisms. It's just, yeah, it's very scary.
Okay, thank you. Thank you very much for the answer. Well, I know that the risk of being sued over using like illegal data or privacy data for academic research, I think that the risk, I think that the risk of using that data is really small because it's for non-commercial use.
Well, in Australia,
yeah.
if we want to use data for research, we have to go through an ethics committee. So we have to apply to an ethics committee, explain how we're going to collect that data, how we're going to keep it private and all of that kind of stuff. So for example, you know, doing data with student information, if I wanted to use student grades, I would actually have to go through a whole ethics process to be able to do that, to link students and their grades and achievements and stuff like that. It's actually requires a lot of work ethics wise to do that. So we're not allowed to publish any research that hasn't been through that ethics process. But we have an external committee that will decide if that's ethical or not for us, or help us work that out.
Okay, thank you for your answer.
No worries.
Great, thank you for that. That was so interesting. I wonder if there are any other questions from any other students while we've got some time.
Maybe I can just wrap up with a couple of comments then. If you're still thinking about it, definitely put up your hand. Just like to encourage you guys too. I mean, I think the ethics stuff is really important, and I'm so glad that student that Nicholas raised that. I think that's a really big thing to think about going forward into your career. There's a lot of ethics stuff in the newspaper at the moment about the ethics in Facebook and those other big companies that are collecting a lot of information, and you guys are on the forefront of that. So what you do is going to affect the rest of us down the line. So you holding your line with ethics and what you do with your data, I think is really something to think carefully about, for the future of everyone on this planet. So yeah, hopefully that you can do that. And with some wonderful visualizations along the way.
Great, thank you so much. Thank you, Dr. Carola, and thank you for Dennis and to you and for letting us this opportunity to speak to your students. If any students have any other questions after the session, please do not hesitate to get in touch with us. But thank you to everyone for coming this morning, and we hope you have a lovely day.
Yep. Thank you for inviting me too.
Thank you.
Yep.
Okay.
Thank you, Belinda. Thank you, Dr. Carola.
Thank you.
Great. Thank you, everyone.
Thank you.
Bye.
So what's next then?
Sesinya udah selesai ya, jadi silakan meninggalkan Zoom meeting.
Okay. Thank you.
Thank you.
Thank you.